Hi, this is Ronald, and today I want to demonstrate some SQL injection vulnerabilities and exploits. So to do this, we'll be running a virtual machine network. So I have a Kali Linux attack machine here, and I have a target machine which is running the XVWA, which is the extremely vulnerable web application. So before we'll be using Kali Linux pretty much, but I just want to go over the setup a little more. So we have both of these machines running on the NAT network. So this basically means that they're sort of running in their isolated network and that they cannot be directly accessed or directly access other machines in my network. Which is good because we don't want this vulnerable machine accessible to other machines on the network. Okay, so all right, so we'll just jump into the Kali Linux. So first thing we'll want to do is actually work out where we can actually pull off a SQL injection attack. So XVWA makes this pretty simple because we can basically select these tabs here, and those will indicate that we can do the attack. So there's no guessing work required. XVWA is here to teach us about these vulnerabilities and attacks. So if we go here SQL injection, we can see the normal usage of this site is we can basically select an item, submit, and it'll give us some information it's pulling from the database. We can also search and it will search the database for that information. All right, so in terms of the SQL, in terms of identifying if this field is vulnerable to an attack, we can do something as simple as just putting a quote here, single quote. All right, and we to submit, and yeah, so we can see that there is an error. So this is an SQL error message. And there's also a tab here, which if we try that same thing, it will tell us nothing. It won't give us an error message. The error message makes it pretty obvious that we can actually put SQL code here. So let's put that to the test. So we have we'll put a 1 here and a quote, a single quote. So what this is doing is it's sort of ending the SQL query that the website is doing, and then it's letting us put our SQL query. So I'll put, this is the SQL query that we're putting in, our arbitrary code, you can sort of think of it. Hash. Okay. Yeah, we see we've got different information now. So we can see XVWA. This is the name of the database. Because we use that function database uh brackets, which gives us the name of the database. So this basically indicates that this tab is vulnerable to SQL queries, SQL injections. We can also try it here as well, just for good measure. So save that here. So this also works where the SQL where the website does not display SQL error messages. So we can basically continue like this, but essentially we'll be manually doing it, and we'll need strong knowledge of the SQL language. So what we can actually do instead is use automated tools. So I'll show you how you can use an automated tool. All right, so what we'll actually need to do is we'll need to actually capture the HTTP post request. So what we'll do for that is we'll use Burp Suite. You can use the free version for this. I'll make a temporary project. Okay, so on Burp Suite, you'll need to go into Proxy. Then we'll open up the browser. So with the Burp Suite, it's basically automatically set up so that it can intercept the requests. You can do that with the regular browser, but just requires a little bit of it just requires a little bit of setting up. So this is a little bit easier. All right, so if we go here, we'll turn the intercept on and we'll just submit one, for example. So this is the post request. This is actually what we send to the website to get to the result. So this is, and we'll apply this to our automated tool. You'll see in a moment. So we'll copy this, and we just need to open up a text file. So we'll text editor, okay, paste. So if we have a closer look at this post request, we can see that it specifies the host, then it specifies the website, the HTTP protocol. It's also indicating a few other things such as the item and the search, the cookie, and all that. Okay, and we'll need to save this. So we'll just make a folder, say call it demo. We'll just name it SQLI.text. All right. So when we'll go back to we'll open up the terminal in here. So yeah, we can see our text file is here. So we'll actually be using something called SQLMap. So SQLMap, and then we'll specify R, which will tell SQL to read that text file and grab that information. So what SQLMap is doing, it'll read this information and it will sort of just automatically pick up the fields where it needs to make requests. Okay, so we'll go back to the here. All right, and then okay, so we'll do -p. So what -p is doing is it's actually specifying which field to put the SQL injection commands. So we've put search, and it'll basically pop the SQL injection code here. We'll go back to it. Then we'll do dbms equals mysql. That's basically us specifying that this is a MySQL database, so it will use that syntax. All right, and next command will actually specify dbs. So this is sort of just this is a good entry command because this will basically identify what databases are present on the system. So we'll press enter. We'll see how that goes. Okay, so we can see that it's grabbed the information from SQLI.text, and yeah, and we can also see the payload as well. So it's done item equals searched one, and then and select from there backend, and yeah, so all right, so it's identified these databases are present. So we can we can do some further exploitation on these. So these ones are sort of just generic databases. This one is probably the more juicy target. So let's go after that one. So SQL map. And we'll next command will specify D, the D argument, which tells us what database to attack, to exploit. And then we'll do space tables. So you can see here that the results are here, that there are three tables present. So there's caffeine, comments, and users. So these are some. All right, so these are three interesting tables we can exploit. All right, let's keep going. And so instead of tables, we'll actually just specify what table we want. So let's say we want caffeine, and what we can also do is columns. So we can, yeah, so we've identified what columns are present, and we've identified their type. So we can see that, for example, description supports up to 1,000 characters. So we can, that's definitely some useful information. All right, all right, we'll try another command. Let's try attacking a different table for this one. So we'll do comments, and then we'll do dash dump. So this dump command will essentially just dump the table and show us all the contents. So let's give that a shot. So this is the full table. So we've got the column names, and we've got one row here. So it's got ID of 1, date 2015. The username was admin, and the comment was keep posting your comments here. If we have a look below, we can see that it's also dumped it to a CSV file, and it's given us the file path, so we can actually head there if we need to. We will actually head there later. So, but let's dump a different table. So this is sort of where the CSV file comes in handy because it will dump the whole table. And if you have a table like this, the formatting is not the best. So we'll actually just head there, make a new tab, cd. Oh, we want to go to the directory. As you can see, I've done this one a few times. All right, so say cat. So if we have a look here, it's a little more user friendly. So we can see we can see there's an item code here, and we can even see a path to the image. We can see a path to the image file that's used. So that's a folder on the website itself. So that could be interesting. But we'll actually head back here, and we saw there was a user tables there earlier. So that's probably going to be a little more interesting. That's something that the website wouldn't want us to see normally. Okay, so we can see that we can yeah, users, and then yeah, there's some password hashes for us. All right, so you want to store hashes to a temporary file? Yeah, we'll say yes. And yeah, we can try a dictionary attack too. All right, let's try that. So I've actually done the dictionary attack before, so it's already done that. But yeah, we can basically if we check here, we can actually see that there's user. We could say the user ID is 1, username is admin. This is the hash, and we've already cracked that hash earlier. And the hash that password is admin, not a very good password. And yeah, so same thing, XVWA. We can see that that's the password hash, user password hash. Yeah, so all right, so that's basic. Yeah, so we've broken into the database, we've got the hashes, we've cracked the hashes, now we have these users' passwords, and we can log in as say the administrator. And yeah, we also have these stored in a CSV file too. So we can do cat. Yeah, and that's automatically stored that in a file which we can refer to later. And it also mentioned something about the hashes here. So we'll do cat. And it's also stored the hashes separately as well. So if yeah, if we did need to do a more stronger hashing attack, we have that hash present already. So yeah, all right. So that basically concludes the demonstration part of this. So as we can see, this little page on the website allowed us to extract a lot of information from the website, including the usernames, a lot of confidential information. So I hope that demonstrates just how powerful the SQL injection attack can be, and yeah, just how much damage an attacker can cause from a badly coded web page, which allows an attacker to directly supply SQL commands and use an effective automated tool like this. All right, so I hope you found that video useful. Yeah, if you have any questions or thoughts, please leave them in the comments. And if you want to see more cybersecurity videos, please subscribe and you'll see more. Have a good day. Bye.